Shambhunath Group of Institutions, shaping the future.
Here, this is a Q. The two positions of Q, that means two ends of the Q. One is a rear end, and second end is known as a front end. Rear end means insert the element in the Q. That end is known as a rear end. Data may be deleted from the Q at the front end of the Q. There are some conditions of the Q I will discuss here. Conditions of Q. At that time, what is the exact position of rear and front? There is no element in the Q. Rear is -1 and front is also -1 because there is no element in the Q. I will discuss some operations into the Q. Then in changing the position of front and rear, we know very well about in the case of stack, the data may be pushed or popped at only one end of the stack. That end is known as the top. If we will push the element into the Q, the top will increase by +1. And if we are popping the element from the stack, the top will decrease by 1. But in the case of Q, if we are inserting the element, then our rear will increase by rear equals to rear plus 1. And if we are deleting the element from the Q, then front will also increase by 1. Fine. At that situation, at that time, there is no element in the Q. The position of rear is -1 and the position of front is again -1. One more condition here. If only one element into the Q, the position of front and rear will equal. Front equals to rear. If only one element into the Q, the position of front and rear will be equal. Example, if we are inserting the element 10, the exact position of front and rear both are equal. Because in previous time I was already discussed, if only one element into the Q, the front and rear will equal. If user wants to insert another data element into the Q, the rear will increase by +1 because I have mentioned here. If the another element like 20, if inserting the element 20, the rear will increase by +1. If we are inserting the element 20, only change the position of rear. Rear is goes 1 and front already constant is 0. So the pointer goes there. Another user wants to insert the data element at the rear end of Q. The rear change. That element is 30. The position of rear will increase by 1 and R is located here. Okay. This operation is going on. And the data element like 40. R will again increase by +1. R is here. The position of front and rear at that time after inserting the element 4 40, R is 3 and front indicate at 0. User wants to add that element insert here. Rear will show there R is here, R is 4 and front is 0. And the data element is 60. R is goes there. The front is 0 and R is 5. Q is full. User wants to add the data element into the given Q. The overflow condition may be occur because there is no index, there is no space. So which condition to indicate the overflow condition? If rear equals to max minus 1. Max minus 1. That means the overflow condition occur. The overflow condition checked by this condition. If rear equal to max minus 1, then overflow condition may be occur. Here. Condition number 1 after Q, because I already discussed in this diagram how to increase the data, how to increase the position of rear. Then if we are inserting the element, the condition, if condition number 1, if we are inserting the element into the Q, only change the position of rear and rear equals to rear plus 1 and rear equals to rear plus 1. How to know the overflow condition? If R equals to overflow condition, if rear equals to max minus 1, this represents the overflow condition. Look here, how to delete the element from the Q and how to change the position of front, because we are deleting the element from the front end of the Q. I have already discussed the data. The Q is work on FIFO principle. FIFO means first in, first out. First element are inserted in the given Q is 10. If we are deleting the element from the Q, that element is deleted from the Q. Then the front is changed if delete the element from the Q. In this position, I have already mentioned at that time front is 0 and rear is 5 and Q is full. If we are inserting the another data element inserting the Q, show the overflow condition, because I have already initialized the size of Q. Its maximum size is 6. User wants to delete the elements from the given Q. The deleted element is 10. Then what is the change of the position of front? If front is deleted, I have already mentioned, if the element are deleted from the front end of the Q, the front will increase by plus 1. If we are deleting the element from this position, because this is the first element are inserted in a Q, front will 0 before deleting the element of 10, front will increase by plus 1. The position of front goes there. Front is 1 and the data element is deleted. Front is 1 and rear is 5. After deleting the element of 10, front shows there and rear is here, because this work on, again I am saying, Q work on FIFO principle. User wants to add the data element deleted from the Q. front is changed. Front is goes there. And the position of front is 2 and rear is 5. And the data element is deleted from the given queue. Front is goes there, here. Front is 3, rear is 5. Another data element is deleted from the queue. Front is 4, rear is 5. Another data element is deleted. Front is 5 and rear is 5. So, I will say, if only one element in the queue, the position of front and rear is equal. To condition number 3, if we are deleting the element from the queue, front will increase by +1, right? And condition number 4, if only one element in a queue, the position of front and rear will equal, because this element to this condition. One element, front and rear, is equal. Okay? If this element is deleted, what is the position of front and rear? There is no element in a queue. The position of front and rear is front equals to -1 and rear equals to -1. If user deleting the element of a given queue, this condition is known as an underflow condition, because there is no element. So what is the exact condition of underflow? If front equals to -1, that represents the underflow condition. This condition is represent to, if rear equal to mass -1, this is represent the overflow condition. And if front equals to -1 or rear equal to -1, that represent the underflow condition. And the first condition of the queue, inserting the element, then r equal to r plus 1. Overflow condition r equal to max -1. Deleting the element of a queue is front equal to front -1. If only one element in a queue, then front and rear is equal. And some conditions here. If condition is this, 10, 20, 30. Here, front is 0 and rear is 2. Okay? In this situation, front is 0 and rear is 2. One important condition I will discuss here. If deleting the element from the queue, 10 is deleted, then front equals to 1 and rear equals to 2. If we are deleting the element 20, then front is 2 and rear is 2. If we are again delete the element, delete the element from the queue at the front end of the queue, we have already said if we are deleting the element from the queue, front will increase by +1, no change in the rear. Then we want to delete the element 30. We want to element 30. Front will increase by +1. Front goes there. At that time, the position of front and rear. Front is 3 and rear is 2. But that time, there is no element. In a simple queue, never front is greater than rear. If front is greater than rear, This condition is represent the underflow condition. That means two conditions of the underflow condition. Very important these conditions. Front is never greater than rear in the case of simple Q. These conditions represent the underflow condition. That means two conditions of underflow. One is if front equals to -1, that represents the underflow condition. And second one is F is greater than rear. This condition is also represent the underflow condition. Look here. Another example of the basic concept of the Q. Basic concept of Q. I have already discussed these 5 conditions of the Q. At that time, the position of front and rear. Front is -1 and rear equal to -1 because there is no element in a given Q. Fine. I have already discussed if there is no element in the Q, this is the underflow condition. This is represented here. And if only one element in the Q, the front and rear is equal. I have already discussed if inserting the element into the Q only change the position of rear. If we are inserting the element into the Q, then 10. What is the position of front and rear? Front is 0 and rear is 0. Why? I am saying if we are inserting the element at the rear end of Q, only change the position of rear. How change the position of front? This is a big contradiction between these two statements, these two conditions. If we are inserting the element in a given Q, only change the position of rear. But how change the position of front? 10. Front is -1 and rear is 0. This condition, according to statement condition number 1, is true. But this condition is so if only one element in a Q, the position of front and rear is equal. One more thing here. First, in empty Q, if we are inserting the element, first check the position of front. If front equals to -1, then change the position of front, then inserting the element in a given Q. Like here, there is no element in a given Q. We check the condition of front. Front is -1, rear is -1. Before inserting the element, first check the position of front. Change the position of front before inserting the element. That means front is 0. Then inserting the element into the Q at the rear end, 10. That time front is already 0. And inserting the element in a given Q, R will then change is -1 plus 1. This is 0. So this condition is true. If only one element in a Q, then front and rear is equal. Right? Because this condition here, this condition, first change the position of front, then that time R is -1. There is no element because I am saying before inserting the element, first check the position of front. If front is -1, then change the position of front before inserting the element. That means there is no element in a given queue. Front is 0 and R is -1. This represents the underflow condition because I have already discussed in simple queue there is never front is greater than rear. Why? This condition what represents front is 0, R is -1 before inserting the element. This condition shows front is greater than rear. That means there is no element. This condition is an underflow condition. So this condition is true before inserting the element 10 that time. Front is already at index number 0. Inserting the element 10, then R will increase by +1 by 0 to 0 -1 to +1 and index number 0 is look here. So the first element are inserted to the queue, then front and rear at the equal position. Front is 0 and rear is 0. Okay. Very simple and very basic concept of the queue. There are some conditions I will discuss here in the front of you. Okay, any question? Then ask to me. You know very well about the basic concept of queue, and the next point is here how to write the algorithm. How to write, so you know very well. There are two basic operations performed: insert the element and delete the element from the given queue. The issue is that how to write for these two operations in queue, how to write the algorithm to inserting the element in a given queue and how to delete the element from the given queue. Right? Algorithm for inserting the element into queue. First step, because you know very well about what is the exact definition of algorithm. Algorithm is well-defined list of steps to solving any particular problem, always written in own words. Step number 1, A, initialization of queue. Initialize queue. Step number B, if we are inserting the element, then first check the overflow condition. Fine. First check the overflow condition. Check overflow condition. If R equal to max minus 1, this condition I have already discussed. This represents the overflow condition. If we are inserting the element in a given queue, if this message is sent, the condition is represent overflow condition. That means we are not inserting the another data element in a given queue. So step number 3, we are exit from a queue. We suppose that insert the element in a given queue. What happened? Exit from it. Insert the data element into Q. First check the front position. If front equals to -1, then change the position of front. Then change the position of front before inserting the element. Step number E. Insert the data element at the rear end of Q. That means change the position of rear. Set rear equals to rear plus 1. And step number F. Set Q rear equals to element, and step number G is H. In slice QQ, check the overflow condition. If R equal to max minus 1, if overflow condition occur, then we are exit from the Q. If overflow condition is not occur, then insert the data element into the Q. First check the underflow condition. If front is -1, then change the position of front. Then we are inserting the element. R will increase by +1, R equal to R plus 1, then data element are inserted at the rear position of Q, and situation is this. Then we are exit from the Q. This is the basic algorithm of inserting the element into the Q. Then how to write the function of inserting the element in a Q, simple Q. The function is, you know very well about what is the definition of functions. Function is a piece of code. There are two basic operations performed in a Q. This is insert and delete. If we are writing the program for implementing the Q, there are many functions to create here, like insert, delete, traverse, fine, traverse, display, and main function. So the one part of how to write the function to inserting the element into the Q. While insert in element, this is a variable integer type. Fine. Element is a variable integer type. Before inserting the element, first check the underflow condition. Look here in algorithm. Before inserting the element, first check the overflow condition. If real equals to max minus 1, print message printf Q is overflow. If this condition is true, then we are exit from the Q. If this condition is false, the next step is going on. Before inserting the element, first check the position of front. If front equals to -1, first change the position of front equals to 0, then inserting the element. First from the message to the user, enter the element, user input the number, scanner percent d because element is integer type, and element, fine. Then real equals to real plus 1, q real equals to element. Function is over. Look here, this is the algorithm for inserting the element in the queue, and this is a function to inserting the element into. Both are similar because algorithm is written onwards, and this is the some syntax is here. But void, this is data type, int element is variable integer type. Before inserting the element, first check the overflow condition. This condition is true, q is overflow, exit from queue. If this condition is false, then this step is going on. If front is -1, then change the position of front is 0, enter, message from to the user, enter the element, scanner input the element, then first change the position of real equal to real plus 1, then q real equal to. Today's lecture is over, and we will meet tomorrow. Thank you very much.
Shambhunath Group of Institutions, a mentor for glorious transformations.